Hello, welcome again. We are covering the subject thermodynamics for civil services mains, IFS and various gate exams. The next topic in the chapter of availability is availability in chemical reaction. There are two types of chemical reaction we will discuss here. First type is in which the temperature of product and temperature of reactant is same as that of surrounding. Okay. Or they are in thermal equilibrium with the surrounding. And in second type, the temperature and pressure both are same for product, reactant and atmosphere or surrounding. Okay, so discussing first type in which system is in thermal equilibrium or temperature equilibrium with the surroundings before and after the process. Then the maximum work obtainable during the change of state is given by that we have found out in the article of reversible work for a closed system. Maximum reversible work for a closed system. That is your W max, that is E1 minus E2 minus T naught bracket S1 minus S2. And E1 is U1 plus MV1 square by 2 plus MGZ1, and E2 is your U2 plus MV2 square by 2 plus MGZ2. Okay, so now if we neglect the changes in Ke and P, then it will be U1 minus U2 minus P naught S1 minus S2 within bracket. Okay, so that is the W max. Now if we assume the same temperature before and after the process, that is equal to surrounding temperature, so this is your T, then this expression can be written as for constant temperature Wt max is equal to U1 minus U2 temperature constant minus T S1 minus S2 temperature constant. Now we will define one term, that is Helmholtz function. Helmholtz function is U minus Ts. Okay. Now this expression can also be internalized in terms of Helmholtz function, that is U1 minus Ts1 is your F1 and U2 minus Ts2 is your F2, or it is the difference between F1 and F2, because F1 minus F2 is your U1 minus U2 minus T bracket S1 minus S2 at constant temperature. Okay, so we can say the maximum work obtainable when system is in thermal equilibrium with temperature equilibrium with surrounding is your difference of Helmholtz function, or we can say the actual work obtainable is equal to or less than the difference of Helmholtz function. For reversible process it will be equal to this difference of Helmholtz function, and for irreversible process it will be less than the difference of Helmholtz function. Okay. So next is when the system is in thermal as well as pressure equilibrium surrounding before and after the process. Okay. So now to study this, because this is the system is in pressure equilibrium with the surrounding, so there will be some PdV work. So to get the expression for work done or useful work done, we have to subtract this PdV work also. So then the availability of the system will be given by this, or maximum useful work that can be obtained is given by this expression, change in availability function. Okay, so that is U plus P naught V minus T naught S minus U naught plus P naught minus T naught S. So this is your availability, and W max is A1 minus A2. Okay, or we can say it is U1 minus U2 plus P naught V1 minus V2 minus T naught S1 minus S. Okay. As pressure is constant, temperature is constant, so we can write it as U1 minus U2 P constant, P V1 minus V2 Pt constant, taking P naught as T, and T naught as T S1 minus S2 at constant pressure. So now this U plus PV is your enthalpy. So this is also can be written as difference of Gibbs. So Gibbs function is H minus Ts, and here we have U1 plus PV1 minus Ts, and U plus P1 PV1 is at H, so H minus Ts1, which is difference of Gibbs function. So maximum useful work in the chemical reaction when where both pressure and temperature are constant is your difference of Gibbs function. So actual work is less than equal to difference of Gibbs function. For reversible work, for reversible process, it is equal to difference of Gibbs function. For irreversible, it is less than difference of Gibbs.